Okay, today our goal is that we can graph systems that contain quadratics. And I'm going to add in here that we're also going to be able to solve them. So we're going to be able to figure out what the solutions are. So these first few are done for us. So the difference is now we have a linear, which we're probably used to, right, from the past, from 8th to 9th grade. But now we also have a quadratic, so a parabola. But remember, our solutions are the points where they intersect. So we're saying, okay, how many solutions are there? There's 2 points where they intersect, so there's 2 solutions. What are the solutions? Those are actually the points where they intersect. So 0, comma, -3, right? The other one is 4, comma, 5. Okay, this next one only has 1 point where the parabola and the line intersect, and it is at the point -2, comma, 5. This last one has 0 solutions, so we say like no solutions, right? Because the line and the parabola don't intersect at all. So I'm going to make you think for a moment here. So in the past, when you just have 2 lines, we either say there's no solutions or there's 1 solution or there's infinite. But if you had 2 quadratics, so 2 U-shapes, what is the possibility of how many times they could cross, right? So you could have something, right, where there's no solutions, like this first one. You could have something where it has 2 solutions, like the second one. You could have something that has no solutions. And then last but not least, if you literally had the same exact parabola, just like we do with equate lines, we could have infinite. So now we're going to have 0, or no solutions. We're going to have 1, we're going to have 2, or we have infinite. So there's a few more possibilities here than what you've had in the past. Okay, this next part we're going to go ahead and graph systems of equations. So we first got this parabola, right? Y equals x plus 2 squared minus 6. So we know the vertex is at -2, -6. After that, you may be like, oh, I kind of forget how to graph my parabola. Sorry, I'm trying to pull up the graph here. So I would recommend at this point that you use like a graphing calculator, or if you're at home, like Desmos is a good website or app that you could use. So I actually graphed both these already, but let's look at some points of just this parabola. So another point looks like 1, -5, and then it's reflected on the other side. I also have a y-intercept at -2. And it is really important here to be really precise in your graphing. And it looks like, what is that, like 1, 3 is also on the graph. Okay. All right. Next we have a linear equation. This one you may recognize, hey, it starts at -2 and then has a slope of 4. Once again, though, if you want to double check things, remember you can always type it into your graphing calculator or the app you're using, and you can kind of take a look. You can see there that it just kind of approaches on this left side, but if I go up 4 over 1, up 4 over 1, you'll notice, yeah, it does just kind of go along the right side there. If I go down 4, left 1, right, it just stays right on the side there. So you'll notice there's actually only 1 point here where it crosses. It only crosses at that one solution, 0, -2. Okay, next one you probably recognize with this one. This is in standard form, so the y-intercept, right, is -3. But after that, you may have kind of forgotten, right, unless we want to complete the square. We haven't necessarily talked about other ways to graph this. I guess you could plug in points, etc., right? So let's go ahead and see what this graph looks like. Okay, so it has a vertex at 1, -4. Then it's going to be reflected. It has y-intercepts at -1 and 3. Maybe I'll do one more point. It looks like -2, 5. So then 4, 5 also is on the graph. Okay. This next one is a linear equation. It says y equals 5. So this one ends up being just a vertical line that goes through the y-axis all at 5. If you're not sure, you can always type that in, right? Y equals 5, -5, sorry. And you can see that black line that you're in. which in this case, these don't cross at all, so we say that there are no solutions. Okay, last but not least, we got another one in standard form. This one you probably recognize two things, actually. So it is in standard form, so the y-intercept is 7. But this time, since there's this negative up front, it should go down. So negative x squared plus 2x plus 7. Oops, sorry. Okay, we got a vertex at 1, 8. And we got another point at negative 1, 4. Oops, that was negative 2, sorry. Maybe one more point, so that looks like negative 2, negative 1. And then I just reflected on the other side. Okay, for our linear equation, right, our y-intercept is a positive 2, and our slope is a negative 2, so that means you're going down to right 1. Down to right 1. Okay, down to right 1, down to right 1. Once again, remember it's important to have an accurate graph. So you'll notice here I didn't quite extend it far enough, so it's fine to go back and see, maybe even with our parabola, it looks like it crosses at a negative 8, negative 5, or positive 5, negative 8. Let's see if that matches up here. Oh, sure enough, it does. So here it extends like that. So in this case, there are 2 points, right, where it intersects. We've got these 2 points, so we got negative 1, comma 4, and we have positive 5, comma negative 8. Okay, we're done with graphing. You can always use the graphs to go ahead and check your answers. It's a good method to know. But let's think back to previous years. How else did we solve systems equations besides graphing? The other ways we solved systems equations is we did them algebraically, right? So we used elimination or substitution. And I'll kind of go through, maybe I'll do one of each and then you can decide which one you like better. Okay, if I want to think about elimination, I'm going to take away one of the variables. So, I'm going to think about maybe getting rid of either the x's or the y's. In this case, you could think about getting rid of the y's. The idea behind substitution is that you're going to replace one of the variables, either x or y, with what it's equal to. I'm actually going to go with substitution here. So we have y equals this. So if I have in my other equation, I have a y, I can plug this in for what y equals. So I have x plus 2 squared minus 6 equals 4x minus 2. Now that everything's in terms of x's, we can go ahead and solve it. So usually with x plus 2 squared, I usually write it as x plus 2 times x plus 2, because then we can go ahead and distribute. So we get like x squared plus 2x plus 4. This is minus 6 equals 4x minus 2. Okay, I'm going to combine the left side. So I have x squared, I've got plus 4x, and I've got minus 2 equals 4x minus 2. So now I got to move it to the other side and solve for 0, right? We've been doing this a lot, solving equations for 0, so I add 2. So then we get just x squared. This ends up canceling, so does that, equals 0. So you can square root both sides. You get x equals plus or minus the square root of 0, but plus or minus 0 is still just 0. So x is 0. But remember, your answer is a point. So we want to go ahead and figure out what y is. So you can either choose the top or the bottom one. I guess the bottom one being linear is a little easier, but we're going to plug 0 in for x and solve for y. So we get 4 times 0 is 0 minus 2, so we get negative 2. So x is 0, y is negative 2. Okay, same thing here. I probably like to do substitution on these. So think about y equals, and I have that. I'm going to plug it in for what y is. So x squared minus 2x minus 3 equals a negative 5. Set it equal to 0, and we're solving quadratics. we get x squared minus 2x plus 2 equals 0. If you tried to factor and says, hey, what multiplies to 2 and adds to negative 2? Fortunately, we don't have anything, so we're probably going to have to use the quadratic formula here. So a is 1, b is negative 2, and c is 2. We plug it into our equation. X equals negative b, so a positive 2, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. So we get 2 plus or minus the square root. When you do the discriminants, right, the b squared minus 4ac, negative 2 squared is 4, minus 2 times 1 times, 4 times 1 times 2 is 8, so 4 minus 8 is a negative 4 all over 2. As soon as you see that negative, that's something that should go off in your head. This is 2 plus or minus. Negative means I, square root of 4 is 2, so 2i over 2. At this stage, I mean, you can simplify that further. We practiced that like last week. But at this stage, we know that there's no solution. In this case, no real solution. The solutions are imaginary. Okay, last but not least, we're going to take what y equals, we're going to plug it in for y in the other equation. So negative x squared plus 2x plus 7 equals negative 2x plus 2. And we also set it equal to 0. I'm actually going to move the x squared to the other side so we get things that are positive. So I'm going to do the opposite of each of those. So this cancels, and on the left side this time we get 0 equals, sorry, that's plus, x squared minus 4x, when we combine terms, minus 5. So if we can factor, that's probably easiest. What multiplies to negative 5 and adds to negative 4? A negative 5 and a 1. So that 0 equals x minus 5, x plus 1, which means x equals a positive 5 and a negative 1. Remember, it's the opposite of what's in the parentheses there. So now we got to go back and find the y values. Probably it's easiest to do the second equation. And maybe here, I'm going to just use function notation for a minute. So remember, y is the same as like saying f of x. So I'm going to do f of 5. So when I plug 5 in for x, I'm going to have negative 2 times 5 plus 2. So I get a negative 10 plus 2 equals a negative 8. We got to remember that goes with 5. Whereas when I do like f of negative 1, right, when x is negative 1, I get negative 2 times negative 1 plus 2. So I get a positive 2 plus 2 is 4. So we have 2 points. We have 5, comma negative 8, right, those match up. The other one is when x is negative 1, y is 4. And you'll notice, it's a little hard to tell here, but you'll notice these actually were the same exact problems that we graphed, so we have the same answers for these problems. Okay, we got 2 more problems to do. I think the idea we've been using so far worked out great, so let's use substitution. We're going to take what y equals and plug it in for y in the other equation. X squared plus 2x minus 8 equals 4x minus 5. Let's set it equal to 0. So we've got x squared minus 2x minus 3 equals 0. So let's try factoring. What multiplies to negative 3 and adds to negative 2, we get a negative 3 and a 1. So we get x minus 3, x plus 1 equals 0. So x equals a positive 3 and a negative 1. And you're probably feeling pretty proud of yourself, but we're not quite done yet, right? Remember, you got to find out what the y values are. So y equals 4 times 3, because that's what we just found out x is, minus 5. So we get 12 minus 5 is 7. Same thing, but this time when x is negative 1. So 4 times negative 1 minus 5. Remember, you could use either equation. I just am using the linear because it's a little easier to plug things into. So then we get negative 4 minus 5 is a negative 9. So we got 2 solutions. We got 3, comma 7, and we got negative 1, comma negative 9. Okay, last but not least, take negative x, and we're going to plug it in for y. So we get negative 8x equals 1 plus 16x squared. So let's add 8x to both sides. 0 equals 1 plus 16x squared plus 8x. You're welcome to rearrange it to standard form. I'm going to guess most of you probably don't super love factoring. you probably prefer the quadratic equation. So let's identify what a, b, and c is. So a is the number next to x squared, so 16. B is the number next to x, so 8. And then c is the constant, so 1. So x equals negative b, so negative 8, plus or minus the square root of b squared. 8 squared minus 4 times a, 16, times c is 1, all over 2 times a, which is 16. So we get negative 8 plus or minus, let's see, 8 squared minus 4 times 16 times 1 is 0. So look at the square root of 0, all over 32. Square root of 0 is just 0. If I add and subtract 0, that doesn't change anything, so there's really only one answer here. Remember when we said the discriminant was 0, it means there was one real answer? So we have one real answer, and it was negative 8 over 32, which I could simplify to be negative 0.25, I'm going to guess you guys like. And then y equals negative 8 times negative 0.25. And we end up with just 2. So there's only one solution here. It only crosses at one point, and it's negative 0.25, comma 2. So this is one of those ones where graphing may not be as accurate because you may not be able to tell exactly where it crosses because it's at like a decimal or a fraction, but it does cross at that one point. If you ever want to check your work to make sure it does work, you can always plug it into the second equation. Remember, y equals 1 plus 16 times negative 0.25 squared. And then you can type that into your calculator and just double check, hey, when I type that in, I end up getting 2, which is what I expected, so it does work. All right, you've got, I don't know, somewhere between like 5 to 10 questions like this. A few ask for graphing, and then a few are going to be expected to do algebraically.